In today's topic, we would be discussing weathering part 2. Chemical weathering. Chemical weathering is the gradual disintegration of rocks due to their exposure to air and water. The processes are enhanced by high temperatures and an abundance of water supply, and are most intense at the base of steep slopes where there is high moisture due to fluctuating water tables. It is common in hot wet climates or humid regions with high temperatures. The major processes involved in chemical weathering include solution. Rainwater attacks and dissolves rock salt to form a solution. For instance, rainwater dissolves calcium carbonate, CaCO3, in limestone, thereby widening cracks and joints in the rocks. Oxidation. This process involves the reaction of oxygen in air or water with minerals in rocks. Most rocks contain a certain amount of iron in a reduced form. The reduced iron is oxidized when it comes in contact with oxygen. The oxidized iron is stable because it is only soluble under extreme acidic conditions. The stable iron oxides are readily precipitated. This causes the loosening of the overall structure of the rocks and accounts for the accumulation of oxidized iron and the formation of laterite in the tropics. Hydration. This is the process whereby certain minerals within rocks absorb water and are chemically altered. This process leads to the formation of hydroxides. The action weakens the rocks, which may eventually disintegrate. Carbonation. This process of chemical weathering involves carbon dioxide in the air turning into a weak acid called carbonic acid. As water from rain enters the ground, the acid reacts with rocks rich in calcium carbonate, like limestone, and alters the calcium carbonate to calcium bicarbonate. The weak acidic water dissolves and removes the calcium bicarbonate. Carbonation is most active in the decomposition of calcareous rocks, especially limestone and dolomite. Hydrolysis. This is the chemical reaction between rock minerals and water, usually with hydrogen as a catalyst. It occurs frequently in the weathering of feldspars and micas, whereby clay minerals are formed. Elation. This is a process of chemical decomposition by organic acids. The decaying plant litter on the soil by bacteria produces organic acids. When dissolved in water, the organic acids enhance chemical weathering, as they have a marked effect on the solubility of certain minerals, particularly iron. The products dissolved in the acid solution are later taken up by growing plants. Biological weathering. Plants and animals also contribute to the process of rock breaking. The roots of trees sometimes grow in cracks, and as they penetrate through, they act as wedges and cause pieces of rocks to break away from the main mass. Burrowing by animals like earthworms also helps to loosen the soil. The activities of humans in road construction, mining, and farming also contribute to biological weathering. Differences between weathering and mass movement. Weathering is the breaking down or disintegration of rock in situ, while mass movement is the movement of weathered materials downslope under the force of gravity. Weathering processes are enhanced by the mineral composition, fracture and joint system, and structure of the rock, while mass movement is enhanced by the gradient of the slope, the force of gravity, and the weight of materials. In chemical weathering, water aids the alteration of the chemical composition of the rock, while in mass movement, water facilitates the movement of materials. Weathering leads to the formation of soil, while mass movement leads to the destruction and transportation of soil. Thanks for watching. See you in the next video.